Welcome back, everybody, for another lesson in AP Calculus AB. Today we're going to be reviewing piecewise functions, how to graph them, how to write equations of them. So let's take a look at this graph shown below. This is a typical piecewise function. Take a moment. We're going to think about what we see here. And if you want to pause the video and kind of just take it in, that's fine. But as I look at this, I notice that, I've got three distinct pieces. I have one piece here that appears to be a kind of a parabola, maybe the equation x squared. I've got a horizontal line segment there, and then I've got this ray here, which appears to be the equation of some line. It looks like the slope might be up 1 over 1, so a slope of 1. And then we also want to take note, because each of these pieces is graphed over certain values of x. So this parabola is everything up to and including x equals 1. The little line segment here, and we'll highlight it in green, seems to be from 1 to 2, but you'll notice there's an open dot there. And that open dot means that the value when x is 1 is evaluated only in the parabola segment. It's not included in the horizontal line segment. So when we have an open dot on a graph, it means that that is a boundary point, but it's not included. Now, this line segment also has an open dot, and it seems to cover the pieces from 2 onwards. So if I were going to write the equation of this line, it might look something like this. I'm going to start it with f of x, because this is a function. It passes that horizontal line test. Each x only yields one y value when you plug it in and evaluate it. And on the graph, each x value only has one associated y value with it. So it has three pieces, and sometimes it's easier, I think, to start with the domain rules, so the values of x. So the first piece, which is this parabola, has everything up to 1 and including 1. And so I have to write it in terms of x is either less than 1 or greater than 1. So here all these x values are less than, and I'm going to put a little equal sign because of that solid dot. The 1 is included in this piece of the graph. So whatever the equation is, it's for all values x less than or equal to 1. So now this equation happens to be a parabola. It has a vertex at 0, 0. It passes through the point 1, 1, which leads me to believe that this is the equation of just y equals x squared. And basically, when you're asked to evaluate these equations, you'll either be given the equation, or if you're asked to write a piecewise function, we generally keep it a little on the simpler side for you, something like this. But you would be expected to know that this is a parabola and the equation is y equals x squared. Similarly, you'd be expected to find this equation here of this little horizontal line segment. A horizontal line has the equation y equals and then the y value. So this piece is y equals 3, or f of x equals 3. And now we need to say what values it goes from. Well, it goes from x is 1 to x is 2. So I'm going to write it like that. X is between 1 and 2. But then I have to pay attention to the closed and open dots. So open dot on the left, closed dot on the right, which means 2 is included in this segment, but 1 is not. Now, the last one is going to be for everything x is greater than 2. Not greater than or equal to, just strictly greater, because we have this open dot. And if I continue this, I know the line segment has a slope of 1, and if I wanted to, I could use the point 2, 2, write it in point slope form like we did in the previous video, and and then solve for y and get it in slope intercept form. Or I could just notice that, hey, this passes through the origin, so this looks like the line y equals x, and it is. So there's my piecewise function, and that's how we construct an equation based on a graph. So let's keep on going. Let's take a look at what we have next. Now, is this function that we just looked at what we call continuous? Now, continuous for our purposes right here, right now, means is the graph connected? So if I go back up and I look at this, this graph is not a continuous graph. And I know that it's not continuous because if I take my pen or my pencil, and we'll use my magical rainbow pen, and try to trace the graph, I have to pick up my pen and move it to get to this next spot before I can trace that part. And then I have to jump and move before I can trace the third piece here. So this is not continuous. It has what we call a jump discontinuity. It has 2 of them, actually. So we're going to be talking more about continuity in Unit 2. But for now, we just want to kind of get that foundation of what does it mean to be continuous. Now, let's talk about what happens when we need to graph a piecewise function. So let's take a look here. We've got this set of equations. We're going to graph it. And sometimes it's easy if you have a lot of pieces or if your equations are a little more complex. Sometimes it's easier just to create a little table of values for each piece. That's kind of how we do it when we introduce this topic. But for these are fairly basic equations. And so I think it's reasonable to expect a calculus student to want to graph these like this. If you have the line y equals negative x, that's the line y equals x with a negative slope. And it's for every value less than 0. So I know that y equals x looks like this. And actually it would continue all the way through. But because it's a piecewise function, it goes up to, but it doesn't include 0 because of the strictly less than. So for all values less than 0, this is what this graph looks like. Now, the next piece is that parabola. And you'll notice that it starts at 0 and it goes through to 1. And so when I graph a parabola, the vertex is at 0, 0, it goes up to 1, and I'm going to try to make it look curvy. But we have these solid dots on the either end of this one because x is equal to 0 and equal to 1 on this interval. Now you'll notice that the green and the purple did overlap, and so that happens quite often. Either it happens or it doesn't, I suppose. But here it closes off on the graph and makes that point connected. We'll talk about that in just a moment. But finally, you've got this horizontal line, y equals 1, and it's for everything greater than 1. So technically, this piece has an open dot there, but because of the closed dot there, it really kind of doesn't matter. But you'll notice now, we have a connected graph. There are no holes in it, there are no jumps. And so as I graph this and trace it with my highlighter, I don't have to pick up my pen to trace any of it. So even though some of the pieces individually have an open dot on them, when you look at the graph as a whole, the function as a whole, which is all three pieces put together, you get a continuous function. Ta-da! So let's move on. Let's talk a little bit about writing equations of piecewise functions. So we did it first in the beginning. Let's take a look at this one and see what it would look like. And actually, if you want to pause the video and try this one on your own to write the equation for this guy, I would encourage you to do that. Here's what the equation is going to look like. So this first little line segment goes from 0 to 1. So when I start out, I'm going to say f of x equals, do my brackets, and it goes from 0 to 1, but it includes 0. So I'm going to put the equal to sign under there. And this looks like the equation y equals x. It has a slope of 1, passes through the origin. Sure enough, that's that equation. So now I'm going to write the next piece. Now the next piece is also a linear function. It has the same slope, but this one, if I continue it down, it's going to pass through -1. Remember, each of these, if this is 1, this is -1. So I want to make sure I pay attention to the scale there. And so this is actually the equation y equals 1x minus 1, which I'm just going to write as x minus 1. And it's for all values ranging from 1 to 2. So 1 is less than or equal to x is less than or equal to 2. So here is my piecewise function. That's what the equation is going to look like. So as we look at these piecewise functions, why do we care about them? Well, they show up in calculus, but more importantly, there's a function that we need to learn how to deal with, and that's the absolute value function. Because later on, when we're asked to look at the absolute value function and do calculus with it, we can't do calculus if there's absolute value bars. We have to find a way around that, and we have to kind of analyze what's happening with the absolute value. So remember, absolute value talks about the distance a value is from the origin. So when we're dealing with absolute value, if the x coordinate is -3, the absolute value of -3 is 3 because it's 3 units from the origin. Now, we have to understand that, we're taught that absolute value takes anything negative and makes it positive. And that's okay to think about it that way. That's a nice, easy, way to remember what to do and how to evaluate it. But really, let's take a look at what's happening. This absolute value function is actually a piecewise function. The left piece, for every value for every value that is less than 0, for every value that is less than 0, we're going to have this line y equals negative x. For every value that is greater than 0, and you can include 0 in this, you're going to have the equation y equals x. It's just a linear function, and that it'll change based on the absolute value function, but just for the strictly absolute value of x function, that parent function, this is how we want to think about it. And so as a piecewise function, it would look like this. You'd have x for all values greater than or equal to 0. You'd have the opposite of x. Remember, negative signs, really you want to think of them as being the opposite of the value. The opposite of x for anything that's less than 0. So if you have something less than 0, like negative 2, the output would be the opposite of that value. So we want to include 0 with the normal x, if you will, the positive x, because technically 0 doesn't have an opposite. 0 is just 0. It's just one of those weird numbers. And so we can't take the opposite of 0. So we always kind of put the 0 with the positive x. That's generally the convention there and the rationale behind it. And before I leave you to think a little bit more about this and do some work on your own, I just want to review just some basics about graphing general absolute value functions. So if you have an absolute value function, recall we have this right here, this a x minus h, and we talk about this equation with the basics, shifting and moving up, down, left, right, and it's important to know those things. But we also sometimes refer to like this value as kind of the slope of the absolute value, and then h and k we call kind of the vertex. So really, if the vertex is supposed to be at 0, 0, the h and the k values, whatever those numbers are, they shift it left and right and up and down. So that becomes the new coordinate of the kind of the point of the v. So if I am looking at an example here, and I have this equation, y equals negative 2. So the negative 2 means that I'm going to have a slope of 2, so my v is going to be a little bit steeper. But then the negative side means that it's also going to flip over. So I'm going to have an upside down v. And then my h value is the opposite of what I see here. So it's going to be negative 1, 3. So that's going to be the location of the point of my v. So when I go to graph this, a nice easy way to go about it is just to go to negative 1, 3. And then I'm going to go down 2 over 1 because that's my slope. If my slope is negative 2, I'm going to go down and over. And if I think about it that way, then I automatically get this upside down v. And then I'll just complete the other side if I know that it's got to be a v. So there's your quick shortcut to graphing these absolute value functions. You can also graph them in your calculator using the absolute value function and your y equals screen. We'll be doing some graphing calculator stuff a little bit later on. But this hopefully has been a nice little review for you of some of the concepts surrounding piecewise functions and all the things that you need to know for absolute value. So my encouragement to you is just to keep on going. You can do this, and yeah, you've got this.